सर आवाज नाही येत.
हॅलो हॅलो, येतं का आता?
हो
येतोय
आता
सर.
येतोय.
ओके. आत्ता पहिल्यापासून आत्ता झाला का डायरेक्ट?
हो आताच
हो
या.
सर. येस सर.
ओके ओके, आय विल रिपीट अगेन. ओके. सो sorry. So before this lecture, we studied the brief history of the artificial intelligence. Okay. So the artificial intelligence is divided. The history is divided into two parts. First is ancient history. Okay, what the ancient people done, and then there was a modern history. Okay, so right from this 1956. Okay, to 2021. This is the modern history. Okay, so in this history, the brief were given is what the people developed in that particular area or those particular years, isn't it? So these all are described in this slide where you can judge what happened to this artificial intelligence, isn't it? So in first phase was 1969 and 1979, where this is first phase or first level where these two scientists, that is the Marvin Minsky and John McCarthy, these were appreciated or awarded for defining foundation for uh, knowledge representation. We can say field-based knowledge. Okay, this field-based knowledge representation and uh, reasoning. Okay, so these were the first phase or first step. Okay, evolution or first evolution. Then second, another two scientists, Raj Reddy and Faringam, in 1994, they developed the expert systems. Okay, and how? What was the base for development? Human knowledge encoding. Okay, so whatever the human knowledge is there, that was used to develop the expert system, and application of the expert system solve the was to solve the real world problems. Okay, so I can't change the color. Okay, so to solve the real world problems, expert systems were developed, but basis for that was the human knowledge. This is the second phase of the artificial intelligence. In third phase, the Jodie Pearl in 2011, she was appreciated for this one, probabilistic reasoning techniques. What is the probabilistic reasoning techniques? It is to deal with the uncertainties, isn't it? So as I told you in one of the example, so a pilotless car is there. You make it smart for certain situations, or you make it intelligent for certain situations. But there are certain uncertainties, isn't it? Suppose you take an example, as I told you, like it is designed for like traffic lights or speed breaker or something, but there is an uncertain situation that if some animal rush in, okay, like suppose another uncertain situation is some person is walking, okay, and right in the middle of the he is having certain the velocity, and right in the middle he stops down. Okay, so when he stops, it is an uncertain situation. Okay, even if you take example of an animal, if animal is running in, and again in between, at the middle of the, at the 70% of the road, that animal crosses again, it takes the decision to u-turn and rush it back again, isn't it? This kind of uncertainties are there, and those all uncertainties you consider in probabilities. Okay, and that is the another development in the artificial intelligence, to consider the uncertainties and have the probabilistic approach. Probabilistic approach means considering the probabilities of the certain events occurring in that particular course of action. Okay, and then last was the these four, you can say, the scientist, that is the Benju, then Hinton and Jan Lecken. In 2019, they were awarded for making the deep learning approach. Okay, so what is the deep learning? It is a multi-layer neural network. Okay, multi-layer neural network. Okay, and all these layers are interconnected, and uh, the information, okay, is extracted by applying this deep learning algorithm or deep learning approach or technique. Okay, so this was in 2019, and it was a critical part of the modern computing. So this is what the evolution you can see. Okay, so if you want to see tell the history of the artificial intelligence, you can write down in these particular four lines. Okay, so first was the uh, field-based representation. Okay, sorry, field-based on representation of the knowledge and reasoning. Second was human knowledge encoding to develop the expert system. Third was dealing with uncertainty, and fourth was the deep learning approach. Okay, so in these four, you can represent the artificial intelligence as a big picture. As first is artificial intelligence, a big circle. Okay, then middle circle is the machine learning. Means machine learning uh, is the part of the artificial intelligence. Okay, it is not the artificial intelligence. Okay, it is the part of artificial intelligence. Means artificial intelligence can be used for machine learning. Okay, but machine learning has its own limitations and its circle is smaller than the artificial intelligence because artificial intelligence, more than machine, it is applicable everywhere. Okay. Then deep learning. Okay. So deep learning can be, or deep learning is a part of everything. Okay. That is artificial intelligence, machine learning. Okay. So deep learning is the smaller circle, but it can be it can be used for refining or improving or enhancing the performance of the artificial intelligence model. Okay, and then the last circle you can see future kinds of intelligence. Future kinds of intelligence means now we know deep learning, but in future there can be another intelligence algorithm can be developed, which will be more superior to deep learning also. Okay, now, and in big picture, you can see the data science circle, which is touching to all of these three fields. Okay, isn't it? Now, future one is just for for the consideration, but the first three circles, that is the AI, ML, and DL. Okay, all these three circles are using the data science circle. You can see. So, data science is basically considering the data, or it is utilizing the data, or it is providing the data, because artificial intelligence, machine learning, and deep learning, all of these three are based on the data. Okay, so that's why data science is the part, okay, or it is the basis for all these three sciences or all the three uh, technologies. Okay, on the time scale you can see artificial started AI started in 1950s, and in 1980s you can see it was applied to the machine learning process. Okay, after 1980s, and you can see after 2010 again deep learning approach was sorted, and in 2020, okay, so deep learning is already coming into the application with the machine learning. Okay, okay, so this is history of artificial intelligence. You can see artificial intelligence development was up to 70. The its application was to machine learning from 80s to 2006. You can see that is the machine learning part, ability to learn without being explicitly programmed. Okay, machine learning and what is the difference between the programming and the machine learning? Because see, computer programming was already there, but we call it as a machine learning. So what is the machine learning? Ability to learn without being explicitly programmed means certain tasks without means certain tasks which are not there in your program. Okay, okay, so then also machine is able to make the decisions, and that is the machine learning. Okay, programming simply help you the what is programmed and decision will be according to program only. But without programming, making decision is the machine learning. Okay, without programming means I am not saying completely there is no program. There is a program, but machine learning approach is on the basis of the whatever the program it has, plus on the basis of the self-learning, or we can say it self-training. The machine makes its program modifications as per the situations which are not there in the program. Okay, and that is the machine learning approach. Then deep learning. Okay, uh, deep learning is learning based on deep neural network, and which was from 2010 onwards, and you can see it is till date. So, what is deep learning? It is the approach to machine learning. Okay, deep learning is basically it is used for the machine learning purpose only. Okay, so one that focuses on learning data representations rather than task-specific algorithms. Okay, so deep learning is what? What is the focus of deep learning? Focus of the deep learning is the learning. Okay, focus is the learning. Okay, we are not like sticking to the program only. Okay, so program is different. Okay, a program may be there, but it will not stick. Okay, it will not stick to program. Okay, it will not to stick to program. It will learn. Okay, its focus will be on the learning. Okay, it makes use of deep neural network which are inspired by the structure and function of the human brain. Okay, so what is the basis? It is using the deep neural networks. Okay, so deep neural networks are like this. Okay, so you can see in the first diagram there is a how the brain works, and in the second diagram that is the deep learning algorithm or neural network. Okay, the deep learning algorithms are based on these neural networks. Okay, so if I increase this, okay, so this is brain how it works. Okay, now you can see the brain. Okay, so this you can see the axon. Okay, axon has the some leading points. They are connected to neural cell body. Okay, and it is connected to dendrites. Okay, this axon. Okay, so whatever is the axon of the previous neuron, that axon is connected to dendrites by this synapse. Okay, again this you can see the electrical signal is going further to the next axon, and next axon again it is connected with the connected to the dendrites by synapse. Okay, by synapse, and these are the axon tips. So in this way, you can see one axon has 4 5 limbs. Okay, or you can say it is connecting more and more number of dendrites of that particular neural cell body. Okay, so there is a nucleus which extracts the information, okay, and pass it on to the next one. Okay, similar to that in neural network deep learning. Okay, so in neural network development, okay, so you can see there is the input layer, that is the input modes. Okay, and there's the hidden nodes. Okay, in second level, and again in third layer there is the output node. Okay, and they are linked, they are all linked together. You can see there to the you can see arrows. Every node is connected to every hidden layer. Okay, every node is connected to every hidden layer. Okay, and all the inputs, okay, x1 x2 x3, they are communicated to from the input node layer to the hidden node layer, and from there it goes to output layer. Okay, so here the decision arrives to the output node layer. Okay, so output node layer, and then output is displayed. Okay, so in this way this deep learning works. Okay, so what is the deep learning? uh, these these are the huge number of layers are there. Okay, okay, so huge number of layers are there. Okay, and that's why they are called as the neural network, or they are using the neural network, and there are a huge number of layers are there. Okay, the data transfers to multiple layers before producing the output. Okay, so before, as I told you, before you arrive for the decision, okay, data is processed in multiple layers. Okay, and that is kind of logic, isn't it? In deep learning there is some logic, isn't it? Okay, so if you want to see this deep learning, then you can easily, if you are playing chess. Okay, so when an opponent is giving certain move, okay, playing some move, okay, then what is deep learning? That you think about that particular move in multiple possible direction. Okay, so that particular single move of a pawn, or maybe a rook, or maybe the horse, or whatever it may be, knight. So that particular move that is been, okay, that the decision to play your move, okay, is related to deep learning. Okay, related to, because you just imagine that particular move, or predict the consequences. Okay, predict the consequences depending on that move in different ways. Okay, what if, okay, what if this, what if this, what if this, what if this, because you have like you have 10 number of chances which you can play, and you have to come to we can say you have to come to very optimal decision, or very right decision. Okay, because you will find if you have 10 play or 10 moves in your hand, all 10 will be all 10 will be right. Yes or no? But deep learning approach, basically, though all are right, but again you have to find out which is the most right, isn't it? Isn't it? So which will gain you more profit in those states, isn't it? So deep learning. Okay. So data has to pass through multiple layers. Okay. And deep learning is used for purpose like natural language processing, drug discovery, toxicology, bioinformatics, and many more. Okay. So there are many applications of the deep learning. Okay. So out of that, natural language processing is okay one of the application. Okay. Then okay, why do we need artificial intelligence? As we are lazy. Okay, what we want, you want ample amount of time, and we don't want the labor. Okay, we don't want the we don't want the labor means minimum. Labor should be minimum. Okay, and you want to save more and more time. Okay, so in less time your work will be carried out by machine itself. That is why we want the artificial intelligence, isn't it? One of the major reason. Okay, so whatever data is there, that is producing huge chunks because of the artificial intelligence, the data development is on the such a large scale that it is in uh, thousands and lakhs of gigabytes. Okay, now GB, thousand lakhs of GBs it has crossed, and it has reached into petabytes also. Okay, so the data is very large. Okay, and now we as human need something that processes and handles data to minimize the strenuous efforts being put into handling it. Okay, so another reason of application of the artificial intelligence. Okay, now next is comparison of artificial intelligence with data science. Okay, so handling the data is data science. Okay, what is data science? Processing and handling the data. Okay, so ultimately, in other words, okay, what is data? Data is the scientific study of data that stores, records, analyzes the data. Okay, so what is the data science? Storing, recording, and analyzing the data. Okay, okay. Now for what? For the benefit of human or for the benefit of interested. Okay, whosoever is using that data, its data has the advantage. For that purpose, you are storing, recording, and analyzing it. Okay. As I told you, the data, like I told you, Android phone applications when you install, they are seeking the permission from you regarding your contacts, gallery, and location. And that data is because of the gallery, because of the social media access of your phone, or the location access, or the access to your contacts or access to your personal information leads to knowing which gender, which age, which locality person is in the interest of what. So according to this particular data, they can analyze, they can after storing and recording, they can analyze the data for what? For developing the business model for particular area, particular age group, particular gender person. Got it? So this is what is the data. Okay. So uh, that is data science and how it is related to artificial intelligence. Okay, so artificial intelligence basically it is based on the data, but what is the application of the artificial intelligence? For managing. Okay, artificial intelligence is for managing the problems and solving the problems. Okay, so to solve the problems or to manage the things, you have or you should you require the data. Okay, so in this way there is a comparison of artificial intelligence and data science. Okay, so data is the basis for artificial intelligence. Okay, but artificial intelligence is not only data, but it is using the data for the decisions, for getting to decisions, or leading to decisions. Okay, or managing problems and solving. Okay, data science is the term for whole set of tools, okay, and techniques by which to analyze the data and extract the insights. Okay, now what is the data science? Data science is analysis of data and extracting the information. Okay, it makes uses of scientific methods. Okay, now what is for that it uses the methods, processes, and algorithms. Okay, now its goal is to discover hidden patterns. Okay, important thing is okay to discover the hidden patterns in raw data to help business improve and increase their volume. Okay, so as I told you the example of the Android applications, okay, when you download and you allow the permissions, with those permissions it can discover the hidden patterns. Okay, okay. So whenever you go to certain location and over there, see, whenever you use the map, in the map, whenever you are using that map, where you stop by, then there are certain the shops, okay, or some apartments, isn't it? So immediately Google asks you, or Google Maps asks you for your reviews about that particular place. Are you aware of this? They are using they are asking you some reviews, isn't it? Because already in the Google Map, wherever you are going to certain locations, some all the geographical informations are already uploaded to that particular, isn't it? So suppose you go for a fuel station, then immediately they are asking how was this and then reviews and all. Okay, and then you give the reviews about that, isn't it? So immediately it can improve the business, isn't it, with that particular kind of uh, you know review given by that particular customer. Okay, so whatever are the things, okay, uh, as these permissions and these maps, all the information, all the data are they so interconnected that whatever you do on that particular Android phone, that becomes the data for that particular company. Okay, and it can be used for improving the services as well as improving the business. Okay, so this is the data science. Okay, so what is the data science? These six parts. Okay, what is first part? Discovery. Okay, then second is preparation of the data. Third is planning of the model. Fourth is building the model. Fifth is communicating the results, okay, of the model. Okay, and operationalizing. Before operationalizing, we are communicating the result. Results are verified, and if results are satisfactory, that can say that whatever the model you have made for this particular purpose, that model is correct. Okay, so then you put it for into operationalizing. Okay, so this already I told you, it is the extracting the insights. Okay, and it uses the scientific methods and algorithms, and for what? For the benefit of business. Okay, this is the data science. Okay, now data science uses machine learning. Okay, data science uses machine learning to analyze data and make predictions. So this can be used in uh, utilitarian prospects. Okay, so machine learning, okay, data science uses machine learning. Data science combines, okay, what is the data science? It combines the machine learning with big data analytics, okay, and cloud computing, okay. So what is big data analytics? Okay, so again, handling the big data, and cloud computing is the storing the data, isn't it? Cloud computing is storing the data on the clouds and or on the server. Cloud is nothing but basically the server. Cloud is not exactly in the sky somewhere, isn't it? So you do not need some other hardware to store the data, isn't it? Okay. So that is called as cloud computing. Sorry, the data science combines machine learning with big data analytics and cloud computing. Okay, it focuses solving the real world problems and always has a human involved, unlike artificial intelligence, where it is the artificial intelligence that takes the action. Okay, so uh, basically it focuses to solve the real world problems. Okay, means data science involves the human. Okay, data science involves the human. Human uses the data to solve the problem. Okay, and instead of human, if you use the machine, then it becomes artificial intelligence. Okay, so again, this is the data science. Already we have seen this uh, uh, four. Okay, these four, and the that is the three techniques: artificial intelligence, machine learning, and deep learning. And all of these three are used in the data science. Okay, so this diagram explains all about the data science. Okay, then basics. Now we will go for the classification of the artificial intelligence. Okay, so there are two classifications of artificial intelligence. Okay, classification based on ability, that is weak artificial intelligence or narrow artificial intelligence. Then second is strong artificial intelligence or general artificial intelligence, and third is super artificial intelligence. Okay, so in three levels of the abilities. Okay, so you can say weaker, and then uh, weaker, then stronger, and ultimately you can see the strongest one, that is the super artificial intelligence. Okay, so first classification is based on what? Ability. Okay, then second classification is based on functionality. Okay, as per Professor Aaron Hines, Michigan State University. Okay, so according to this professor, okay, based on functionality, okay, you have these four. Okay, what are these? Reactive machines, limited memory, theory of mind, and self-awareness. Okay, so these are the four classifications on the way based on functionality. Okay, on the basis of ability, they are weak, strong, and strongest. Okay, and according to functionality, first is reactive machines, limited memory, then theory of mind, and self-awareness. Okay, next. So this is the classification of the types of artificial intelligence. Okay, first is on the basis of ability. You can see on the left side, and on the right side it is the based on functionality. Okay, so first is narrow artificial intelligence on the basis of on the basis of ability. Okay, first is narrow, second is general, and third is super. Okay, and on the basis of functionality, first okay, so next. Now types of the artificial intelligence. Okay, so on the basis of ability, they can be strong or weak. Okay, okay. So what is the basis for the strong and weak? What is the basis for the strong and weak? It will be depending upon amount of tasks it can conduct. Okay, how much is the amount of task it can conduct? Basis on that, that model can be weak or strong. Okay, then okay, so uh, the types of artificial intelligence. Okay, huh. So I was telling you about why they will be strong or weak. They will be strong or weak uh, on the basis of task, amount of task it can conduct. Okay, so what is the weak or narrow? Weak or narrow? Take just a moment. Huh? Okay, sorry for the disturbance. Okay, so what is the weak or narrow artificial intelligence? Okay, so it a weak artificial intelligence, it also called as narrow because it is designed to handle just one particular task. Okay, so that's why it is called as weak. And the speech recognition can serve as good example of weak artificial intelligence. Okay, so the programming is such that it is only able to identify spoken words and phrases and convert them into machine readable format. Okay, so speech commands. Okay, when you are giving the speech commands, your words and phrases are fixed. Okay, and then it can analyze or it can convert that particular into machine readable format. Okay, so that is the weak artificial intelligence. Okay, what do you mean by weak or narrow? It can handle for limited work or we can say specific work. Okay, okay, so one particular task. Okay, then it is a weak or narrow artificial intelligence. Okay, second type of artificial intelligence is the strong or general. Okay, so in contrast, we can apply a strong artificial intelligence or general artificial intelligence to accomplish various tasks. Okay, again another addition is it will learn also. Okay, so along with accomplishing the tasks, the learning is also possible or learning is also added. Okay, and that makes this model a strong artificial intelligence or general artificial intelligence. Okay, so for the example, AlphaGo is a computer program that plays a board game Go. Okay, so what is this in the game? Basically, whenever you are programming a game, okay, then the game has to improve itself. Okay, isn't it? Because see, depending upon the level or competency of the opponent. Okay, because suppose the different people are playing that particular game, isn't it? And every person is not having the same expertise or same excellence. Okay, so as per the level, okay, as per the the we can say pro. Okay, normally we say we are very pro in that particular game, isn't it? So as per your skills, as per the skills of the person is playing with that computer, the computer has to improve the program, improve the game, isn't it? And that is we can say the stronger, or we can say stronger general artificial intelligence. Okay, so it learns and improves self according to the situations arising in the game, and it has beaten Lee Sedol, a South Korean professional gamer. Okay, now this is a board game. Okay, and this is a board game normally the people are playing, and artificial intelligence, when you include the strong artificial intelligence in that, it can beat, or it has already beaten the Lee Sedol, which is South Korean professional gamer. Okay, so it can defeat a person also. Okay, and that is a strong level of artificial intelligence or general artificial intelligence. And what is the third part? Is the super artificial intelligence. Okay, so super artificial intelligence is this third category. Okay, apart from the strong and weak. Okay, so and it is called as the SAI, that is the psi, or we can call it as a super artificial intelligence. Okay, so basically this refers to the time when capabilities of computers would exceed that of humans. Okay, so super artificial intelligence basically it is referred, or it is the inferred as this. There will be a time, okay, when computer capabilities will be far superior than the human, isn't it? Okay, so it's a hypothetical concept basically, and it can perform any task better than human with greater efficiency without any human error. Are you getting this? Okay, so they will be far superior than the human. Okay, though they are machines, though they will be the models, though they will be the programs and computer programs, and but still those will be very much far, or where we can say superior. Now super artificial intelligence, do you know, now the computer engineers, okay, computer engineers are using this, suppose the coding techniques for development of the various softwares. But see, the time will come that computer itself will develop the software in various programs at the same time. Okay, with the minimum time, without any error, isn't it? So whenever you are developing a software is nothing but a particular code. Okay, series of codes. Now in this series of codes, what happens? There are always, like when human is building this particular software, and there are the chances that there are many errors included in that, isn't it? There may be syntax error and something and all that. Okay, this and that. Those are all human errors. But see, if consider if there is super artificial intelligence, then definitely someday the computer will make a software. Okay, and that software will not need the testing also. It will be one take go. Okay, one take go means the right first time you use it, it will be errorless. Got it? So that is called as the super AI. Okay, that will be the super artificial intelligence level. Okay, so super artificial intelligence level example can be a game or a chess game. Nobody can defeat the computer. Okay, that is the super artificial intelligence level. Or you can take any example where it can outperform the human brain capability. Okay, so that is the super artificial intelligence, and on the basis of functionality. Okay, another types are given on the basis of functionality, and first part of the we can say first classification on the basis of functionality is the reactive. Okay, so reactive machines basically these do not store memories or learnings from the past experiences. Okay, so reactive machines do not store memories. Okay, and the past learning is not stored in the reactive machines. Okay, so they simply react to the surroundings and choose the most optimal solution amongst the available alternatives. So reactive machines means like suppose if you take example of an animal, okay. So the reactive intelligence, like suppose there is a dog, okay, and suppose in past like that machine, sorry, the dog is dog bite was to a particular suppose human, maybe his own friend or own owner, but it cannot it do not store it to the next memory, or do not keep it in memory, it do not store into memory, and also it do not take learning from that also. Next time if similar incidents happens, then again it will react the same way. That is the reactive thing. Okay, so in reactive machines they do not store the memories, or they do not learn from the past experiences. Okay, they are just simply reacting whatever the situation comes, according to that it will react. Okay, it will react. Okay, even in case of like suppose there is a person who is getting angry, okay, for certain kind of situations, or certain kind of occurrences, okay, or certain kind of the behaviors. Okay, so every time it will react to this that particular situation in same way. That is the reactive type intelligence. Okay, according to the functionality. Okay, so that particular person is not learning from his past experiences. Okay, even though it is not storing into getting like if some person. Okay, see what happens. We say many times we get similar experiences with the same some a particular person, isn't it? So what is that? It is not changing that person. Okay, the behavior of that particular person is not changing. Okay, though you experience the bad things about it. Okay, and still you go many times to that particular person, and you are getting same results. So they are reactive people, and we can say that similar to that there are the reactive machines. Reactive machines are not storing anything in the memory, and they do not have any, or they do not keep any, or they do not learn from the experiences. Okay, they simply react to the surrounding and choose the most optimal solution amongst available alternatives. Okay. Now forget about the human reactive process, but here in artificial intelligence, they simply react to the surroundings, and during reaction, whatever is the most optimal solution, it will that solution amongst the available alternatives it will choose. It cannot infer from its prior experiences to build on. Okay, so prior experiences are not there, so it cannot infer that to um, to develop the model or something. So there is no upgradation of the model. Whatever is the situation, according to that, it will act. We all remember IBM's Deep Blue chess playing supercomputer, which defeated international grandmaster Gary Kasparov. Okay, now here in IBM's Deep Blue uh, chess playing supercomputer. Okay, now this defeated the Gary Kasparov. Now it was based on reactive. Reactive means what? Uh, it will not store past experiences because what happens in chess? You can be deceived with the past experiences. Okay, you can be deceived with the past experiences, isn't it? Because last time suppose I played this move, okay, XYZ move, and if I play the XYZ move, that XYZ move has 5, 6, 10 possible outcomes. But in the past, I have played the outcome number 2, and now if you judge on the basis of past experience, then I played on the second outcome, then you will make your moves as per second outcome. Okay, you means the computer will make the move as per the second outcome. But then this time I will play the third outcome or fourth outcome, and I will defeat computer again. Isn't it? So uh, reactive machines, on the basis of whatever is the possible outcomes at the particular moment, on the basis of that, it is taking or it is choosing the optimal, and because of that, that supercomputer could defeat Grandmaster Kasparov. Okay, so this is what is the so Deep Blue is capable of identifying pieces on the chessboard and even can predict what could be the next move of its opponent. It can also choose from next possible moves. However, it is unable to retain any memory and bring past experiences into the picture while making decisions. Okay, so it can also choose the possible moves. Okay, next possible moves. Okay, but it is unable to retain any memory. Okay, and bring past experiences into the picture while making the decisions. Okay, so it is unable to make the decisions, okay, on the past experiences, which means that the previous moves will not affect its future decisions. Okay, what is the reactive machines problem, or we can say advantage? Previous moves will not affect the future decisions. Okay, previous moves will not affect the future decisions. Then next is the limited memory. Okay, so according to functionality, the another part, another step or another type of artificial intelligence is limited memory machines. Okay, so what is it? It can retain in transient manner. Okay, data can be retained in transient manner, meaning that its memory lasts for short period of time, much like goldfish. Computers are more intelligent now. Let's not make fun of them, isn't it? Because like means because already why there is a laughing, because the computer already have the big storage nowadays, isn't it? Not in computer itself, but if you are connected to internet, there is a multiple or thousands of GBs you can purchase. Okay, to that particular computer. Okay, from the server. Such a system can use experiences occurred in the recent past to inform the future decisions. Okay. Now, from the reactive to limited, what is the difference? Uh, Short memory. It has short memory. So, recent past it can remember. It will not remember the ages. It will not remember the data of years. Okay. So, it will remember the data from recent past. Okay. However, it can add these experiences to its database or library. Okay. So, this can be added, okay, to the database or library. Okay, for example, a self-driven car stores the speed and pattern of changing lanes. Okay, speed and pattern of changing lanes, etc., of the cars around it, and navigates on the basis of this data. However, perpetual storage of these observations does not occur. Okay, so it is not storing for longer data, but that car has some cars moving around that particular car, isn't it? Your car is the self-driven car, and around you there are 4 5 cars, isn't it? So short memory, limited memory is what? It will change the speeds and pattern changings lane. lane changing patterns, okay, of the cars which are around that particular self-driven car. That data can be used for the navigating. Okay, so when this car is navigating, it will use that short data or limited data. Okay, and that is the example of the limited memory artificial intelligence. Okay, so this is 10:57. So here we will stop today, and another part we will see in tomorrow's lecture. Okay, so let me mark your attendance first.